Euclidean Geometry, Rider 7. This set of riders does not have a reminder each time like riders 1 to 6, but just to remind you here to start with that there's the thought process as detailed in the circle geometry strategies, an earlier video in this series. This set of riders now brings everything in, including ratio and proportion, similar triangles, proportional intercept theorem, etc. So there's our first one. Cyclic quadrilateral, we have D1 equals D3, and we have to prove these facts here. Now, as established earlier, we do have a thought process when we have this sort of proof to do, where we're multiplying lengths of lines together. So the first thing we do is we form fractions. Doesn't matter which way around we do it. Doesn't matter what we take underneath, because we can do the horizontal, the vertical and horizontal tests. So let's do a vertical test. And we see ECAB, and straight away that throws it out, because what we're looking for is two feasibly similar triangles. So that's out. So, going that way, yes, we found two triangles that are feasibly similar. They already have a pair of angles equal. So let's have a look at that. D1 equals D3. Yes, we already know about that, given. B1 equals C2. Let's have a look. B1 and C1, I mean. Well, they're angles in the same segment. Have a look here. There and here. Angles in the same segment. There we are. And the final angle, which is A1 and 2 and E2, have to be equal by angle sum triangles. Angle sum triangle. So, let's get into the proof. Set out the same way as with congruency. 1, D1 equals D3 given. Then we have B1 and C1 equaling one another by angles in the same segment. And finally, the angle sum triangle. So we state our similarity. Remember, this is very important to get the right order. So angle A equals angle E, angle B equals angle C, angle D1 equals angle D3. Because now we can obtain our relationships out of it. So I can look and say, well, where do I get an EC from? There, you see. And it will have to go over AB. There we are. So I have AB. So left CD. So I say, well, I get a CD. It'll have to go over BD. And then we hope that it comes out as what we have to prove. And it does. So let's look at the next part now. Once again, we do the same thing. We have AED and BCD, two triangles to prove similar. And it's feasible they could be similar as well, I'm sure. So, if we have a look, we say, well, which angles in those two triangles are likely to be equal? A1 and B2. I hope you can see it, that it's angles in the same segment. A bow tie there. D1 and 2 and D3 and 2. You see, because that is equal to that, D1 equals D3, if we add 2 to both, we'll have a common angle, which means that D1 and 2 must equal D3 and 2. So, angles in same segment. D1, D3 equal given, and therefore D1 and 2 equals D3 and 2, because D is common. And then we have angle sum triangle for the remaining angle in the triangles E1 and C1, 2. So, proof. There are angles in the same segment. We do a little mini proof within here to prove that D1 and 2 equals D2 and 3. And then the angle sum triangle. State in the correct order, angle A equals angle B, angle E equals angle C, and angle D, 1 and 2, equals angle D, 2 and 3. Now we have to get this out of it. So I look for an AE, and there's an AE, and it must go over BC. So I've now used the AE, I've used the BC. On the other side, I have to have AD on top, and it has to go over BD. Yippee, it is what we need. Put this here just because there could be some fussy mark who expects it. And it follows that that is the case. Now, often in these cases, the result to this is actually algebraic and what you've proven already. Most of these have something algebraic at the end. So what we do is we say, well, have a look at what we have. If we look at, I look at ACBD, I haven't seen ACBD before. I look at ABCD and I say, oh yes, there it is there. I look at BCAD and I see, yes, there it is there. So what I'm going to do is I'm going to take these and add together equaling those. So let's try it. We're going to call that 1 and that 2. And we're going to add 1 and 2. Now, if you have a look at the algebra here, well, first of all, we have what we need on the right-hand side. On this left-hand side, have a look. We have a common BD, common factor we can take out. So we look at the AE plus EC, and we look at the diagram and say, well, AE plus EC, there we are, that's AC. And we have proven what we have to prove.